Hello everyone, today's topic is synchronization of synchronous generators. We all know that and we have seen that a synchronous single phase synchronous generator supplies the power to the load by acting as a voltage source wherein the frequency is decided by the prime mover which is connected. And also similarly the current and the power factor can also be determined by the excitation what we are providing to its field and impedance of the generator and load. Now, whenever we connect number of generators and all these number of generators must be operating at the same voltage and they are required to be interconnected electrically, and also the bus bars are used as the common electrical component. Here bus bars are nothing but the copper rods which operate at the constant voltage which we are decided with. Now, in the process of switching of an alternator to another alternator with a common bus bar without any interruption in between is called as synchronization. So alternatively we can also define that connecting two alternators in parallel without any interruption is nothing but synchronization. You can connect a number of alternators in parallel. So generally what we call is a synchronous machine is one which is synchronized normally is called as incoming machine, and if similarly alternator is connected to a bus bar which has many alternators already connected to it, then no matter whatever may be the power it is supplying, then the alternator is said to be connected to infinite bus bar. We say it has infinite bus bar. So generally infinite bus bar is one wherein the frequency and phase EMF remains unaffected by the general changes in the condition of any one machine connected to it. So we say that these machines are nothing but they have constant frequency and constant voltage bus bars. So when we talk about synchronization, there are few conditions or what are the necessity conditions for the synchronization. The first necessary condition is the terminal voltage, that is terminal voltage of an incoming machine must be same as the bus bar voltage. So the voltage should be same with respect to bus bar as well as incoming machine. Next, the frequency must be same. Second one, the frequency must be same as that of incoming machine as well as that of the bus bar. And similarly, when we connect the external load, the phase of the alternator's voltage must be identical with that of the bus bar voltage. So if we satisfy these conditions, then we can go for the synchronizations. Generally, synchronization of single phase alternators is done by two important methods. One we call it as lamps dark method and the lamps bright method. Now we can see in the figure here. So this is the lamps dark method. Lamps dark method. In this method, as you can observe from the diagram, the lamps have been arranged. The alternator which has to be synchronized, or we can call it as incoming alternator, and it consists of two lamps connected across it. So you can see here lamp 1 and lamp 2. Now there is a switch terminal of the same phase. Here the voltage for both the alternators or two alternators are measured with the help of a voltmeter, and the lamps are connected in such a way that the polarity and the frequency of both the machines can be checked simultaneously. Now no resultant voltage here will appear across the switch terminals of the frequency of the two alternators, and it is not exactly same as well as their voltages are in exact phase opposition. Now what happens under this condition? These lamps will not be glowing and the voltages for both the machines are having the same maximum and RMS value, and they are in exact phase opposition to one another. So resulting voltage in the local circuit will be 0. Now whenever there will be two voltages and they are in exact phase opposition, that we call as angle between them is 180 degree, then the resultant EMF ER will become 0. At that time, if that switch is not closed at that particular instant, then what will happen? The voltage across the lamp will go on rising here, and the synchronization will not be proper. So what we need to do, the alternate darkness and the brightness of the lamp will not indicate whether the incoming alternator is running fast or slow. So at that position, the exact synchronization, the speed and the incoming alternator is generally adjusted. How? To make the light speeds are produced at every slow speed, and alternators are synchronized during the middle of the dark period. So at that dark period, we will exactly be knowing that the resultant voltage here will be 0. So the word here, what you mean by middle is nothing but at the lamps will not glow even though there is a sufficient voltage across them. So this is how the lamps dark method is utilized in order to achieve the synchronization. Similarly, we have lamps bright method, as you can see in the diagram. So generally it is very much difficult to judge the correct instant of zero voltages in lamp dark method. So that method is being replaced with the lamps bright method. In this method, generally we are going to introduce the lamps as shown. So here the lamps remain at the maximum brightness whenever there is no difference in the voltages for both the machines. So whenever we have more sharpness and accurate lamp brightness, so we will be able to achieve the synchronization, because the glowing and the lamps are much more sensitive to the changes in the voltage at the maximum brightness. So easily we will be able to achieve synchronization using the lamps bright method. So this is how the two techniques are being utilized in order to achieve the synchronization. Hope you understood. Thank you.